Hi everyone and welcome to QSO 321 People, Planet and Profit, and the topic is inventory management. And we're going to use continuous review system to analyze inventory position of one of the company's items to see if the company is ordering the right amount or if it is ordering more or less. The problem says a discount appliance store uses a continuous review system or Q system, and one of the company's items has the following characteristics. It has demand, which is regular demand, and this is 10 units per week. We can assume 52 weeks per year. And the ordering cost or the setup cost is $45 per order, and holding cost is $12 per unit per year. We are given lead time, which is 3 weeks, and this is constant. Then we are also given standard deviation in weekly demand, which is 8 units. And also we are given the cycle service level, which is 90%. And then we're given a number of questions here. So what we can do first is to put this information in a model. So let's open Excel and create the model. So the first thing we can do here, let's write a model. And so we will put all the information we have in the spreadsheet. And so we are given the demand or the regular demand, and so we can write it like this. And so the demand here is 10 units per week. We are given 52 weeks, somewhere right here, 52 weeks a year. I'm doing it a little different from what we did in class, but it's the same. And so if this is the information we have, we can actually find the annual demand. Remember, all we are looking for is the annual demand. And in this case, we can find it if you can put the equal sign and take 10 units that we need per week times the number of weeks in a year. And so in this case, we can have 520 units. And so these are not per week, but per year. So that's information which is given. And we are also given S, which is ordering cost per order. And in this case, it is $45. And also that's per order. Also, we are given holding cost per unit per year, and that is $12. And in this case, it is per unit per order. It is per unit per year. And then we are given lead time, which is 3 weeks. So at this point, we can actually find the reorder point. As we discussed, the reorder point equals to the regular demand times the lead time. And so we can put equal sign, and then we will click on the demand or the regular demand times the lead time, which is 3 weeks. And so in this case, we know that we will need to reorder when we have 30 units left, because we can sell these units within 3 weeks, where each week will take 10 units. But we will find another reorder point once we consider the given information. And so let me write information which is given. We are given a standard deviation, which is 8 units. And this means the average of the fluctuations from this regular demand is 8 units. And that's what we call the standard deviation. We are also given the cycle service level, and the cycle service level which is given is 90%. We could be given 95, 80, or any percent, but at this moment we are given 90%. So we are required to find economic order quantity, the desired safety stock, and also the reorder point. Now, the best thing to do is to follow the functions or the formulas which we have been working on. And so remember, we try to find the ordering cost per year. So how many orders are we going to make in a year? And in this case, we will call this ordering cost. And the formula to find the ordering cost is the annual demand divided by the quantity times the ordering cost per order, which is also the setup cost. We can find as well the holding cost per year. And so in this case, it is Q divided by 2, which is constant, times H. Let me write here constant, which should be 2. And so this is the holding cost per year, the overall holding cost per year. We can find the total cost. And in this case, the total cost is the ordering cost plus holding cost. We will get the yearly total cost of inventory. So having this information, we need to find Q. And so the formula for this is the square root of the constant, which is 2 times the annual demand times the setup cost. And then we will divide by the holding cost. And so we are going to use this formula to find Q. It's good to start with the Q, and then we'll be able to find the OC and HC. Our intention here is to find if this quantity is the desired quantity, or we call economic order quantity, or not. And we can find if the quantity is economic order quantity where OC equals to HC. So let's find the Q, and I will put the equal sign and type SQR. So that's the square root. That's the square root. And I will add another bracket. And so I will click on the constant, which is 2, and that will be times the annual demand. And our annual demand is 520. And that will be times the setup cost, or ordering cost per order, which is 45. And so I'm going to click this, and then I'll close the bracket, and then that will be divided by the holding cost per unit per year. So this one, and then I will close the bracket. And so once you have done this, then you can enter, and you can see that we have this quantity. Normally, this quantity could be 62 or could be 63. It all depends on the items or the units. If these units are integers, meaning that they cannot be in fraction, then we can actually say it is 62 or probably 63. But at this time, I'm going to leave this as it is. So now we know the Q, and all we need to do is to find OC and HC. So I'm gonna click there and put equal sign. And to get OC, we will take the annual demand, which is 520, divide by Q, which is this one, and then times S, or ordering cost per order, or setup cost. And then you can enter, and you can see that we have 374.70. So let's find HC as well. And this is Q divided by 2 times H. So Q is 62 divided by constant, which is this one, times H. And H is 12. So if you click that, you can enter, and then you can see we have the same cost. The ordering cost and holding cost are the same. And so this quantity is actually the required quantity or desired quantity. And so we can put the star, which means that the Q is the economic order quantity. And that we have answered the first question, which says, what is the economic order quantity for this item? And we can say that for this particular item, the company can order this quantity, and the cost will be, the ordering cost will be the same as the holding cost. So we can find the total cost in this case. So you can put equal sign and then type summation. And so we can sum these two. And if you can close the bracket and enter, we can see that this is the total cost of holding, the total cost of ordering and holding this particular item for the whole year. So we can copy this, we can copy it, and then we can paste somewhere like here. But now we need to paste just as values. So we can go, if you're using Mac, you can paste special and you have to paste as values so that you won't copy the function. So just paste as values, and then we can explain about this later. So we could actually change the quantity. Here we can put, let's say, 62 and enter. Now, if the quantity is 62, you can see that the OC is a little bit more than the holding cost, but we can say they are very close. They are very close. So we can put 63 and enter. You can see as well that these are pretty close. So if the units are integers, then we could consider 62 or 63. That will be okay, but you can see it will be very close. So that's what I wanted to show. And then we will need to consider or to look at this reorder point, where we could order when we have 30 units left, because the weekly demand is 10 units, and therefore for 3 weeks we are going to have 30 units that we can assume that they will satisfy up to the time when we can receive new inventory. However, this is actually in average, and so we are not sure if these units will in reality take us for the 3 weeks. We can get more orders in between, and therefore we may run short of this product. So to reorder when we have 30 units left may not be desirable in reality. So that means we need to keep a little bit more. So if we receive more orders, then it won't be a problem. However, we don't want the company to keep more units than it requires, because the more units you have, the more the holding cost will be. So we need to find the additional amount, or the right additional amount, that we can keep to be in the safe side, and so we call it the safety stock, the additional stock which will keep us safe, that we won't run short if demand changes. So we have standard deviation and the cycle service level. This will help us to find the desired safety stock, as the question says here. Now let's add the safety stock. The safety stock can be found by using the following formula. It is the Z times the standard deviation over the lead time. That is the formula for safety stock. So the Z value times the standard deviation over the lead time. So we need to know how we can find the Z, and also how we can find the standard deviation over the lead time. So to find the standard deviation over the lead time, we're going to take the standard deviation which is given, and here you can see we have 8 units, and this will be times the square root of the lead time, and the lead time is this value. So how to find Z value? In this case, we can use Excel function. Just put equal sign and type norms inverse. If you type NORMS, then you will find the norms inverse. So in this case, if you click it, then you will see that you need to put probability, and our cycle service level is 90%, so that means it is 0.9. So assume this was 95, then we could put here 0.95, or if it is 80, then it could be 0.8. However, now it is 0.90, so you can close the bracket and enter. And you can see we have 1.2815 and so forth. So that is the Z value. Now let's find the standard deviation over the lead time. In this case, you're going to put equal sign and type use the standard deviation which is given, and we have 8 units, times the square root of the lead time. So type SQRT, select this, and then we're going to put the lead time, and that is 3, and then you can close the bracket and enter. So we have this value, which is the standard deviation over the lead time. Since we have Z value as well, then we can actually find the safety stock. So here we can say the safety stock, and so we can put equal sign, and then we can take the Z value as it is here, times the standard deviation over the lead time, which is the standard deviation times the square root of lead time, which is this one, and then you can close the bracket and enter. So here we have these units, and we can say that we need to keep these extra units. So if they are integers, we can actually keep 18 units. If they are not integers, then we can keep this with fraction. Okay, so now we know that this is the additional amount that we can add when we reorder, or at the reorder point. So we can add to these 30 units. Remember, before we said we need 30 units that will take us 3 weeks, and each week takes 10 units. However, we need extra units that will put us in a safe side. and the extra units will be 18. So the reorder point, including the safety stock, or we can say the desired reorder point, is actually it is just put the equal sign, take 30 plus this amount and enter. So let me click here and add that information. It is the demand, or the regular demand times L, or which is this one here, the regular demand times the lead time, but we need to add safety stock. So this is actually the desired reorder point. And now we will need to find the holding cost, of the safety stock. So we need to hold these additional units which we have to keep during the lead time. And so the holding cost of the safety stock will be yearly holding cost of the safety stock can be found by putting equal sign, and then we will use this formula that will be the Q, and our Q is 18 divided by 2, which is constant, and so I'm going to click on the 2, and that will be times the holding per unit per year, which is $12. And so you can enter, and you can see that the cost of keeping these additional units for the whole year will be $106.55. So that's all with this application number 3. And now we can look at for final question. And this says Enos company uses a continuous review system. And one of the company's item has the following characteristics, almost the same as application number 3. And we have demand 20 units per month. And you can see we are not dealing with the weeks, but we are dealing with the months, and we have 12 months. And in this case, the lead time is 2 months, and that should be constant. And so we are given the regular demand, and also we have the setup cost per order, and also we have holding cost per unit per year. So this information is pretty clear. And we are also given the standard deviation in weekly demand. This should be in monthly demand. That should be in monthly demand. If you consider this to be in weekly demand, then that means this should be times the number of weeks in a month. So please consider this as the monthly demand. And then the cycle service level is 80%. So we are supposed to create the model and be able to find the quantity and see if OC equals to HC. And that's the information we have here. We need to find the OC and also HC. And then we need to find the total inventory cost per year. And that is the OC plus HC. And in this case, we are told to compare the cost of the optimal policy with the current policy, which is Q. The optimal policy is the economic order quantity, or the desired quantity. And then we can look at the current policy, which is 150, to see how much cost will be saved by switching to the optimal ordering cost. If we are ordering 150 at this moment, how much it costs, and then we need to see if we order the right amount, how much can we save. Because if you order to the optimal, then that means the cost will be less than ordering less or ordering more. So then here we are asked to find the desired safety stock and also the desired reorder point. And if you can follow this example, you will be able to do this question. And so if not, please let me know.